I'm going to go ahead and graph here a polynomial function that is an even fourth degree polynomial function, and it is not factored. So we're going to go ahead and also need to factor it. I would say this will be similar to problems 91 through 96, but also the factoring part would be similar to 5.2 problems 51 through 68. Okay, so fourth degree, that's also positive. There's a 1 in front here, positive 1. And even, that means that if I put negative infinity in here and raise it to fourth power, it would be a big positive number that would outweigh all these, and therefore it's going to go up on the left. And if I put positive infinity, it would certainly be positive infinity again, and that will go up on the right. And so we're expecting the endpoint behavior to be up on the left and up on the right. Okay, now if I go ahead and calculate the y-intercept, it's easy because 0 in for x would leave just this last term standing. That'd be 0, 8. And let me go ahead and put that on the graph. Okay, then here's where we're going to go ahead and break this function down into its factors right here. So we're going to use the rational zeros theorem here. The potential rational zeros would be taking 8, and we're going to break it down into its possible factors, which is plus or minus 8, plus or minus 4, plus or minus 2, and plus or minus 1. And q is just plus or minus 1. So the ratios of p over q are going to give us the potential rational zeros of plus or minus 8, plus or minus 4, because I'm just putting these over the q values of 1, plus or minus 2, and plus or minus 1. So what we're going to do, excuse me, is we're going to put all of these in our calculator. We're going to put the function in our calculator and allow it to help us with choosing among these any zeros that are from this potential rational zeros list that are zeros of the function. We could put all 8 of these values into the function and test them that way as well, but that would take quite a while. So I'm going to go ahead and let me get my calculator and we'll put this function in there and take a look. Okay, so I'm going to go ahead and put in x to the 4th minus x to the 3rd minus 6x squared. Oops, I got to go ahead and fix this here a little bit. And then plus 4x and plus 8. Let me just double check that and compare here. It looks like we got x to the 4th. Good. Minus x cubed minus 6x squared plus 4x plus 8. I believe I'm in a standard window, and I could check that. I'll just go ahead and hit 6. This is the way I start these out, just to see if it would fit in the window as is. And if not, we'll have to go ahead and adjust it. It looks like I'm good. I'm getting all the minimums to show up and the maximum to show up here. So let's go see if we can find at least one of the rational zeros from the list, if there are any rational zeros from the list. Sometimes our real zeros, our x-intercepts, are all irrational. But in this particular case, it looks like this is crossing at -2 and -1, and also touching at 2. And all of those values are on this list. I'm going to double check it, though, just to make sure that they are. And I'll just go ahead and pick, let's say we took this one right here, right? So this one right here is, negative 2, and let's just test it to be sure. So I'm going to go ahead and use the table feature here. So I'll hit second table, and let's throw 2 into the function, and look at, I do get 0. So that tells me that that definitely is a 0 of the function. That's no different. What I just did with this table is as if I would have plugged 2 into the function and looked to see if I would get 0 for y. Okay, so now I found one of the zeros. One of the zeros is at 2, 0. Now I'm going to try to break the function down using that 0 and synthetic division. It says use the 0 from the step above in division and then the quadratic formula. Now don't forget though, I have a 4th degree polynomial, so I'm going to use the 2 to do division, but then after that I'll only be down to a 3rd degree level. I'll have to go ahead and divide again before I could get down to the quadratic level, right? Okay, so let's get started here. We'll give this a try. So I'm going to put 2 into the original function, which is, and I use in synthetic division, I use the coefficients off of the function. And I'm just going to go ahead and move this up here. And the first coefficient was a 1, then a negative 1, a negative 6, a 4, and an 8. I bring down the first number, that's a 1. I go ahead and say 2 times 1 is 2. I add here, that's a 1. 2 times 1 is 2. I add, that's negative 4. 2 times negative 4 is negative 8. I add, and that's a negative 4. And 2 times negative 4 is negative 8. And as I hoped and expected, if 2 really was a factor, it would, x minus 2 should divide evenly into my polynomial function. And the result is this, is x cubed plus x squared minus 4x minus 4. And what that really represents is the division. If I looked at my original function, which again is up here, right? If I took that and I divided it by x minus 2, I got this for a result right here. Okay, now I need to break this down. So I'm going to go ahead and take one of my other zeros that I had off of the graph and take a look here. One of the other zeros that I had was not only at negative 2, but also at negative 1. And so I could go ahead and I could take one of those zeros, I could say negative 2, and that should divide into here also. So let's see. So this would give me 1, 1, negative 4, negative 4. And I bring down a 1. Negative 2 times 1 is negative 2. I add, I get negative 1. Negative 2 times negative 1 is positive 2. And I get negative 2. Negative 2 times negative 2 is 4. And I get 0. Now, I'm down to the quadratic level of x squared minus x minus 2. And I should be able to go ahead and set this equal to 0. In other words, where y is 0, and get the remaining zeros of the function. And let's take a look. So if I did that, I'd have 0 is equal to x squared minus x squared minus 2. And if this factors, then I have the remaining rational zeros. If it didn't factor, then the other zeros might still be real but irrational. But it does look like on my graph so far. Take a look here. What do I have? Well, I have this situation where I used so far the zeros of 2 and of negative 2. So I'm expecting another 2 for a 0 and a negative 1 if I go to factor this, because this have a multiplicity of 2 to bounce off like that. So I only used positive 2 once. So let's see what happens here. My anticipation is that I'm going to get a negative 1 and a positive 2. Let's take a look. So this does factor into x minus 2 times x plus 1. And when I use the zero product property, setting each of these to 0, I do get an additional 0 of 2 and also a 0 of -1. Okay, so now I could go ahead and collect all 4 of those, 1, 2, 3, 4, and I'm going to go ahead and put those in the summary box up at the top here. And I don't know, let me see if I could. So I have this, I had 2 occurred twice, so that is a multiplicity of 2. And by the way, that also seems to fit what I had happen right here. And so what's happening too, by the way, is, you know, our work here is matching our graph, and then it also is just being recorded here in this table, right? And so we had a multiplicity of 2 for a 0 of 2, a multiplicity of 1 for a 0 of -2, and a multiplicity of 1 for a 0 of -1. Okay, so it touched here at 2, it crossed, and it crossed. Now, we're going to go ahead and come up with the maximum turning points. Well, you know, if we didn't already look at that graph, we knew that the maximum turning points could only be up to 3. It always could only be up to 1 less than the degree. Okay, and then we're going to go back to the calculator and come up with the maximum and minimum points. And so let's take a look here. Well, we got a minimum here, we got a maximum here, and we have another minimum. So let's use second calculate, and we'll go to minimum, and let's go ahead. We got to go and move it so that we are to the left side of that, enter, and to the right, enter, and back into that zone. And the minimum minimum point on this graph is -1.57, -3.12, and I'm going to record that right here. So that is -1.57 and -3.12. And I'm also going to plot that point, and that is right here. -1.57 and -3.12 would be right about here. And by the way, too, I could put my zeros in while I'm at it. And so I have a 0 at 2, -2, and -1. So -2, -1, and 2. And then I also have a maximum point that I could go ahead and calculate here. And that would be hitting second calculate again, and then I'd go ahead and pick maximum, which is number 4, and I go up here, hit enter, I go up around the turn there, hit enter, I back up, and that maximum is 0.32 8.64. So let's put that down. 0.32 8.64, and let's put that on the graph here. 0.32 is about a third of the way over, and 8.64 is just a little above our y-intercept. And I think that's enough information that I'm going to go ahead and get the graph, and this graph would come down, come through that 0, hit my minimum, come back up, go up there, and come back and bounce because of the multiplicity of 2. And that is a graph that's approximating what I had right here. Okay, now, it wouldn't be bad for me to go ahead and record on the graph the coordinates of the max and min as I try to go down through these final steps here. It'll be nice to refer to those values. So let me go ahead and do that. This point here, the minimum, remember over here, was -1.57 and -3.12. And the maximum up here was 0.32 and 8.64. Okay, so they're the coordinates that I'm going to refer to as I take a look at these last 4 questions. So the first one is the domain, all the possible x values. Well, this thing is, this graph is angled this way and this way. Eventually it's going to cover all possible x values as inputs, and so it's going to be from negative infinity to infinity. The range, though, is limited. The lowest y value is at the y coordinate of this minimum point, which is negative 3.12. So I'm going to go ahead and say that the range starts at negative 3.12 and it maxes out at infinity, because this will go on forever up on both of these sides. Okay, what about this? Well, the increasing and decreasing intervals of the function is really what domain values produce that kind of output behavior. So by the time I'm done answering this right here, I will have the domain broken up into areas of increase and decrease of our graph, but they will sum up to negative infinity to infinity. So let's just take a look here. Well, on the graph, and let me see if I can get this in here. I might have to zoom out just a little bit. Let's see if this will work. If not, I'm going to have to just move this a little bit here. Let's see. Okay. So I think we could see the graph fairly well here, and I'll just maybe have to keep moving this up and down just a little bit. But for areas of increase, it started here to increase from this x value of negative 1.57 up into this x value of 0.32, the x coordinate of this. I mean, the output's increasing over those inputs, right? When you put in negative 1.57 all the way through 0.32, you're getting increasing outputs. And that's what it means for an interval of increase. And so this will be from negative 1.57 through 0.32. That was one area, or one interval of increase. And another interval of increase is from this 0 all the way to infinity, as far as the x values that are producing this increasing behavior of my graph. And so that's going to be from 2 to infinity. Okay, let's work with the decreases. The decreases, well, it decreased, let's see, it's decreasing here all the way from negative infinity to negative 1.57, because this really is angled this way. And so all the way back to negative 1.57 would be a decreasing interval. So I'm going to say from negative infinity to negative 1.57, I have a decrease, and there's another decrease right here. So that's going to be from 0.32 to 2, from 0.32 to 2. Watch what happens. I told you earlier that we really should have the equivalent of negative infinity to infinity right here. And let's see. It decreased from negative infinity all the way to negative 1.57. Then from negative 1.57 to 0.32, it increased, right here. It increased from negative 1.57 to 0.32. Then from 0.32 to 2, which would be this right here, from 0.32 to 2, it decreased. So we have this segment right here. And then from 2 to infinity, which would be this last piece, it increased. And that made up negative infinity to infinity for our overall domain.